The next topic, what we are going to see is frame relay. Frame relay is a virtual circuit wide area network. So what is frame relay? Frame relay is a virtual circuit wide area network. So it operates at higher speed. What is the speed of frame relay? It is 1.544 megabits per second to up to 44.376 megabits per second. Frame relay allows bursty data. What is bursty data? The data which is having different transmission rate. It is called bursty data. This frame relay will allows bursty data. Frame relay operates in the physical and data link layers. So in two layers, this frame relay will be operating. One is in physical layer and another one is in the data link layer. So this frame relay allows a frame size of 9,000 bytes. What is 1 byte? 8 bits combined to form 1 byte. So it is having 9,000 bytes, which can accommodate all local area network frame sizes. This frame relay allows a frame size of 9,000 bytes. So this size is enough to accommodate all the local area network frames. Frame relay allows a frame size of 9,000 bytes. Already we have seen. Frame relay is less expensive than traditional WAN. This frame relay, it is less expensive than traditional WAN. This frame relay, there is no flow or error control. In frame relay, there is no flow control or error control. What is the advantage of no flow control and error control? If there is no flow control and error control, the transmission speed will be increased. If you are adding more and more flow and error controls, then the time taken to transmit, it will be more. It provides fast transmission capability for more reliable media. So since it is having no flow control and error control, it provides a fast transmission capability for more reliable media. And for those protocols that have flow control and error control at the higher layers. This frame relay is not having any flow control and error control, but it provides fast transmission capability for the reliable media and the protocols which have flow control and error control at the higher layers. Next, we are going to see the architecture of frame relay. So this is a frame relay network. So yeah, this is a LAN. This LAN is connected to this frame relay network through a router. So this frame relay network is a WAN and it acts as a backbone WAN. Okay, it acts as a backbone WAN. This frame relay provides two types of virtual circuits. One is permanent virtual circuit and another one is switched virtual circuit. These routers are used to connect the LANs and WANs. So here in this diagram, you can see these routers are used to connect this LANs and WANs. And this frame relay is having two types of virtual circuits. One is permanent virtual circuit and another one is switched virtual circuit. Next to virtual circuit. The virtual circuit in frame relay is identified by a number called data link connection identifier. So what is the name of virtual circuit in frame relay? It is data link connection identifier. The source and destination may choose permanent virtual circuit or switched virtual circuit. They can choose either permanent virtual circuit or switched virtual circuit. So first one is permanent virtual circuit. In permanent virtual circuit, first a connection has to set up. Next, the corresponding table entry is recorded for all switches by the administrator. So once a connection is set up, then in each routers or switch, the table entries are made by the administrator. Next, an outgoing DLCI is given to the source and incoming DLC is given to the destination. So what are the two DLCs we are giving? An outgoing DLCA to the source and an incoming DLCA to the destination. Now, what are the drawbacks? This permanent virtual circuit is having some drawback. One drawback is it is costly. Why? Because the two parties, that is a sender and receiver, has to pay for the connection all the time, even when it is not in use. Next one is a connection is created from one source to one destination. If you want to connect one source with the 2 or 3 destination, then again you have to make individual connection from the source to destination. So this is also a drawback. These are the drawbacks of permanent virtual circuit. Next one is switched virtual circuit. This switched virtual circuit creates, it creates temporary short connection that exists only when data are being transferred between source and destination. So what is switched virtual circuit? The switched virtual circuit will create a temporary connection that exists only when there is a data transfer. After the data transfer, it will be terminated. Okay. This switched virtual circuit requires establishing and terminating phases. Next one is frame relay layers. So this frame relay is having 2 layers. One is physical layer, another one is data link layer. So how many layers it is having? 2 layers. One is physical layer and another one is data link layer. First, physical layer. In physical layer, no specific protocol is defined. There is no specific protocol defined for the physical layer. So it is left to the implementation to use whatever is available. You can use whatever is available, and no specific protocol is defined for the physical layer. It supports any protocols recognized by ANSI. Okay, it supports any protocols that is recognized by ANSI standard. Next one is frame relay frame. This is frame relay frame. So in the frame relay frame, you are having flag, address, information, frame check sequence, flag. These are the fields that is coming in the frame relay frame. So in the frame relay frame, you are having these information, that is flag field, address field, information field, frame check sequence, and flag. Now in address, the fields are data link connection identifier, command or response, extended address, again data link connection identifier, forward explicit congestion notification, backward explicit congestion notification, discard eligibility, extended address. These are the fields which are coming in the address. So first we are going for DLCI field. So it is the first bits of the first byte make the first part of DLCI. This DLCI is having 2 parts, the first part and second part. The first part is nothing but the first 6 bits of the first byte, and the second part is nothing but the first 4 bits of second byte. The DLCI is placed in 2 places, that is in the first byte and in the second byte. In the first byte, it occupies the first 6 bits, and in the second byte, it occupies the first 4 bits. So totally 10 bits. These bits are part of the 10-bit data link connection identifier defined by the standard. Next one is command or response. it is provided to the upper layers to identify either a frame is a command or response. And it is not used by frame relay, but this command and response, it is used by the upper layers to identify whether the frame is a command or response. Next one, extended address. So it indicates whether the current byte is a final byte of the address or not. So what is extended address? It indicates whether the current byte is a final byte or not. So if extended address value is 0, means another address byte will be coming, and this is not the final byte. If EA is equal to 1, means the current byte is a final 1. So next one is forward explicit congestion notification. So this FECN bit can be set by any switch to indicate that traffic is congested. So if the traffic is congested, then FECN bit will be sent to 1. And this FECN bit informs the destination about the congestion. What FECN will do? FECN will do or inform the destination about the congestion. Next, BECN, backward explicit congestion notification. This BECN bit is set to indicate congestion problem in the network. Now, this backward explicit congestion notification, this bit informs the sender that congestion is occurred. So the source will slow down its sending rate to prevent the loss of packets. Okay, this BECN will inform the sender about the congestion. So the sender will slow down its process of sending, so it can prevent the loss of packets. Next one, discard eligibility. This discard eligibility bit indicates a priority level of the frame. What it indicates? It indicates a priority level of the frame. If D is equal to 1, that indicates that if congestion occurs, this particular frame can be dropped. To avoid congestion, that particular frame can be dropped. So this bit can be set by either sender of the frame or by any switch in the network. So this bit can be set by either the sender of the frame or any switch in the network. Then extended address. To increase the range of DLCI, the frame relay address has been extended from the original 2-byte address to 3 or 4-byte address. This is the 3 address format. This is a 2-byte address. This is a 2-byte address and this is a 3-byte address. 2-byte means 1 byte is equal to 8 bits. So 16 bit. Okay. This is a 3-byte address and this is a 4-byte address. These are the 3 address formats of extended address. Next one is frame assembler and disassembler. So this frame assembler and disassembler is used to handle the frames that is coming from other protocols like X.25, ATM or point-to-point protocol. So in order to handle the frames coming from other protocols, this fraud is used. It assembles and disassembles frames coming from other protocol. It can be implemented as a separate device or as a part of a switch. Next one is voice over frame relay. So it sends voice through the network. The voice is digitized by using PCM and it is compressed. And the result is sent as data frames over the network. But the quality of this voice over frame relay is less when compared to the circuit switching network. This feature allows inexpensive sending of voice over long distance. If you want to send voice inexpensively for a large distance, then you have to go for voice over frame relay. Next one is local management information. So this local management information is added to the frame relay to provide more management facilities or features. In order to add more management facilities, we are going for local managed information. We are adding this new facility to the frame relay. This local management information provide a keep alive mechanism to check if data are flowing or not. So this local management information will check whether the data are flowing or not. Then a multicast mechanism, it is also having a multicast mechanism. The multicast is nothing but sending from one sender to many receivers. That is multicast. Okay. So this local management information is having a multicast mechanism that allow a local end system to send frames to more than one remote system. This LMI is having a mechanism to allow the end system to check the status of switch. An end system can know about the status of switch by using this LMI. Next, congestion control and quality of service. This frame relay also provides congestion control and quality of service. Now, what does it mean by quality of service? Quality of service is a set of attributes related to the performance of the connection. Next, congestion control is controlling the excessive traffic in the network. So these are some of the information regarding this frame relay.